Hello, my name is Anne Franz, and I'm the Executive Director of the New Manufacturing Alliance. We're so glad you're here with us today to learn directly from women who are in the field of STEM. Um, Today's event is an opportunity for you to hear firsthand why STEM professions are a great career for men and especially women. Today, I'd like to introduce our three career speakers that will be sharing their stories with you today. Jill Thiede is the Associate Dean at Northeast Wisconsin Technical College. Courtney Wenzel, she's an engineer with Aaron's Co. And Taryn West, she's with KR West. Let me now share the screen with Jill. Welcome, Jill.
Great, thank you, Anne. I appreciate the opportunity to talk to folks. And I really appreciate the opportunity to talk about STEM careers. I've been in industry for almost 30 years now as an electrical engineer. So I'm excited to share with you a little bit of that story with you as to what I've been doing in engineering and what you could be doing and the opportunities that exist. So just want to make sure, can you see my screen now, Anne? Awesome. As I mentioned, I have a bachelor's degree in electrical and computer engineering. And I also went back to get my master's in business, and I'll talk a little bit more about that in a moment. I always like to start these presentations with talking about what is engineering. And folks, come up with a lot of different definitions, and there's a lot of different ways to look at it. But I really think the key thing for folks to think about with engineering is it's about solving problems. There's other folks who focus more on the pure theory, the physicists, the mathematicians, the chemists, and that's great. They're looking at theory. But as engineers, we like to solve problems. And I always talk to folks about, why do you want to become an engineer? And a lot of times folks will say, well, you can make a good living, and that's generally true. But that's not necessarily the reason you should go into engineering. Another good reason, thing that folks say is, I'm good at math and science. And I tell you, yep, that helps. That definitely helps. If you like math and science and you're good at it, engineering is a great path to go down. But I think the number one reason why folks should think about going into engineering is if you're really fascinated by how things work and you want to make them work better. I think that's the key thing that you really want. When you have that, you like puzzles, you like solving things, and you want to make things work better, that's the hallmark of a good engineer. I think it's important when folks think about engineering that there's a bunch of different types of engineering. So when you go to college or the university, you can learn about electrical engineering or chemical engineering or mechanical engineering. And that really is just the type of tools that you'll be using to solve problems. Will you be using the electrical skill set to solve electrical problems, or chemistry for chemical engineering problems, or biomedical? You'll be using that mix of both physics and chemistry and electrical to solve medical type equipment problems. There's all these different types, and depending on which of those tools you like best, that might lead you to one type of engineering or another. But I think it's really important that folks, especially women, understand that there's tons of different jobs that you can get within engineering. It's not just sitting behind a desk doing design. Research and development are key parts of engineering, but it's not all there is in engineering. There's marketing, there's teaching, there's technical sales, field service. If you really like working with people, there are lots of opportunities in engineering to use those skills. And that's really what my career, what I'm going to talk to you about, what I've done. So real quickly, what can an engineer, or what have I done? The first thing I would tell you is I went to school at UW-Madison. I loved my time at Madison. I was a member of the Society of Women Engineers. When I first went down there, I wasn't thinking that was that interesting or helpful. And then I realized, this is a really great group. One of the things I'd recommend is on their webpage, they have Engineering Tomorrow's Careers. It's a camp over the summer. Now, this past summer, unfortunately, they weren't able to have this week-long camp where the students, the girls, high school girls, I think sophomores and juniors, can stay on campus and learn about different careers in education. It's a great opportunity. Hopefully next summer they'll be able to have the camp, but it's something for you to look into. The other thing I did when I was at Madison is I was part of other groups, IEEE, which is the Institute of Electrical and Electronics Engineers, and Phi Beta Tau, which is an honor society. But these groups, when you're in university, are really important for developing not just, you get your technical training, but they help you develop some of those other skills. The other thing I'd tell you is getting the opportunity for internships and co-ops is really important. So while you're in school, you can actually get a job and be paid to do engineering work and learn about engineering. And you don't have to have skills going in there. They're going to help get you the skills you need to be successful. So I had the opportunity to work with Eastman Kodak out in Rochester, New York for 2 summers and a semester. Way back when I was working on digital photography, and it was a great opportunity to learn about research and development. Then I went out to California and worked with Hewlett-Packard for the last summer before I graduated, and I got to do marketing, working with customers to understand what is the customer need, and then working with those people back in product development to say, what can we make? And trying to bring those two together. When I graduated, I moved into manufacturing. So after being in New York and California, I came right back home to where I grew up, right back here in Green Bay, Wisconsin. And what was great about manufacturing, you think about all these paper mills that we have in this area and all of the different types of places. You'll hear more about Aaron's and other companies. Manufacturing is a great place to learn more about your skills and your craft. It's a 24/7 operation, at least my opportunity was. So there was lots going on at all times. I got to manage projects and really learn about how do all these parts fit together. And I really learned how to work on teams. So my team and the 12 folks who I worked with, we were responsible for making all the bounty that came out of Green Bay. The next couple years of my career, I spent doing technical marketing, and this is really, an opportunity that folks don't think about when they're going into engineering. But if you like working with people, you like doing presentations. I was into forensics and drama in high school. It's a great opportunity to use your technical skills while also getting to interact with lots of different people. So I got to do things like negotiate projects and write specifications. I sold projects that were anywhere from $400,000 to $26 million. But it was this great opportunity to work with people. The last couple years of my career, I spent working in Industry 4.0. So I don't know how much you've heard about Industry 4.0, but right now we are in the 4th industrial revolution. You might have heard about it back in your freshman year social sciences when you were learning about the first industrial revolution, where we started mechanizing and using steam power, to get the steam engine working. The second industrial revolution, where now we brought, the assembly lines and brought electrical power to it. Back in the 1980s and 90s, we had the third industrial revolution, which was adding computers to those lines. And now in this 4th industrial revolution, we have the capability to get data, big data, all kinds of information from manufacturing processes and use cloud computing to store that information and make those processes that much better and more efficient. So some of the key technologies that you hear about when you hear the Industry 4.0 or the 4th industrial revolution is augmented reality, where people put on these headsets, they can see a piece of equipment in front of them, but we can lay additional information in front of them that can help them operate that equipment more efficiently. Similarly, we have additive manufacturing. Many of you probably have 3D printers in your high schools where you can now make a design and print that right out on their 3D printer. So these are all examples of Industry 4.0 technologies that are really revolutionizing manufacturing and technology. So for my last 2 years, I got to work with a team saying, how are we going to use these technologies to provide, to make our production more efficient, higher quality, and more productive. And that leads me to my final stop so far as an engineer, is moving over to Northeast Wisconsin Technical College as an associate dean. So I've been able to, start in research and development during that co-op, spent a lot of years, 10 years in manufacturing and project management, 15 years to 20 years in technical marketing and sales. And now I get to work with students and help them learn more about engineering and really start their careers. So now I support 7 different programs that are all engineering related. I help the college with working on our Industry 4.0 strategies, how our engineering folks can work with the information technology folks and really provide additional new courses and new certificates for our students. I help recruit students and faculty, and I support 15 faculty as they're teaching these courses. It's a really interesting area because I love the opportunity to work with students who aren't sure exactly what they want to go into, but they know they like puzzles, they like solving problems. And we have a lot of great programs at TC where we can help folks develop those skills. So as you're looking at careers, I have just a couple of quick words of advice. The first thing is not just technical skills are necessary. You also need a lot of skills in other areas. How do you handle conflict? Developing your leadership skills, developing your communication skills. And the other part is not just those technical skills, but some business skills. Learning about finance and, how do you justify a new project? And again, those leadership skills are really important in business. So the things that I would really encourage you to do now, as you're thinking about what kind of career you're interested in, is I would tell you to join clubs at school and attend these type of webinars to learn more about STEM careers. This is a great chance to learn a little bit and talk to folks and get to learn about all kinds of opportunities. The other thing is tour your colleges and your universities. I'm going to tell you, I really think you should think about starting at like a local technical college, like an NWTC. We have programs for 2 years. You can get your associate degree, and we have a program to bridge you to a 4-year program where you could then take the 2 years you've done here and then go to UW Oshkosh or go to UWGB to get a 4-year university degree. And the last thing is I am a huge fan of those internships. You're never going to learn more than when you're actually doing the work. We have a program at NWTC called Earn and Learn, where while you're in high school, you can get an internship with a local company and they will pay you to be doing work while you're earning and learning. So that's kind of my history of, oh, and the last thing, in your family, find people who have STEM careers. And this year, rather than just, I don't know this year at Thanksgiving, but next time you see them, ask them more questions about their job. Ask them about a typical day. Ask them about what they love about their job. And hopefully you can learn a little bit more about what kind of STEM careers are out there and what might be a good fit for you. So that said, that was kind of my perspective on engineering and where I think there's great opportunities for young women to move into the engineering fields. Thanks, Ann.
Great. Thanks, Jill. That was so informative. I really appreciate it. I just love your career pathway. You definitely didn't just stay in the same job for all your career. You continue to advance and change jobs and have different opportunities. Plus, I see that in your educational background, you have a bachelor's of science degree and then a master's degree. So learning has been a big focus in your career, hasn't it?
Exactly. And I think, for folks who go into STEM careers, we're always learning new things. Science doesn't stand still. That's so apparent right now with this COVID crisis, what we're learning. And it's the scientific method every day. We're out there learning, getting data, developing hypotheses, and proving what is really happening. You can never stand still in a STEM career. So that's why it's so important that if you're curious and you're interested in, that's the type of curiosity of a lifelong learner that makes sense to go into STEM careers. But you're never bored. You always get to be learning new things. And that's what I love about my career in engineering and where it's taken me.
Great. Thank you so much. Next, I'd like to introduce Courtney Wenzel from Parents Co., who will be presenting about her career field. Courtney, thank you for being with us today.
Yep, thank you guys for having me. So I'll share my presentation so I can show you guys some pictures and information. All right, so hello, I'm Courtney. I'm a mechanical engineer 1 at Aaron's company. This is a picture of me at my makeshift commencement ceremony, which was me just taking a selfie stick and taking pictures of myself around campus as I just graduated this last spring during the pandemic. So fun stuff. So I'll kind of go through my journey from basically where I started really enjoying engineering to where I am now, which is fresh out of school and in my first full-time position. So I've always really liked the math and science stuff, and starting in middle school was really where I got to apply that in a way outside of the classroom that really allowed me to investigate kind of what stuff I liked or didn't like. So Future City competition was the first thing I did in 8th grade. So our team got together and we built a physical city, and we also we played the Sims computer game, and we got to play and build a city there and had to try and make money and actually have a viable city in the video game, as well as something physical that we made out of cardboard and recycled bottles and stuff like that. So that was really cool. Then moving on to high school, I took a lot of engineering focused classes because I knew that was something that I liked in addition to the math and the science. So I did Project Lead the Way classes. The Intro to Engineering Design was the first one that I did, and it's basically the same as the first couple classes I took in college, and a lot of those principles I'm still using now even in my job. So that was a really awesome class, and I highly recommend those classes because I know even some colleges will give you college credit for some of these high school classes. So that's a really great program. And I also took construction class, so that was less in the computer on the paper working through problems and more, okay, let's build something. So the top right picture there was a house that we actually built to scale. We had to come up with these drawings and figure out how we would want to build a house, and we built it all to scale. So if this house were made in full scale, everything would be up to code. All of those studs are at the correct length away from each other. So that was a really cool thing to learn about how to build a house. I could never do that. Actually, this was all just hot glued together. So that was a really cool experience. And then I also was part of the physics club. So this was our award-winning cardboard boat. Again, we got to make something, test it out. And although it came back and had completely soaked through and fallen apart, it had made it to one end of the pool and back, and we won first place. So those are really cool things that I did in high school that made me kind of figure out I wanted to have a career in mechanical engineering. So that's how I got to Milwaukee School of Engineering, where I went for my bachelor's degree in mechanical engineering. And I also had a physics minor. And the main thing, probably the highlight of my career there, was the Formula Hybrid team that I was a part of. So this was my junior year. We won competition, which is worldwide, so we can say we are international champions. So this was a car I had worked on for 3 years. I worked on the suspension, the impact absorbing foam at the front of the car, the battery boxes. So it was a really cool experience, especially learning about the hybrid technology that's used in that. And we're seeing that more now in industry with hybrid and electrification. Some really cool classes that I took were based in FEA, which is finite element analysis, and 3D printing. So that's what my other pictures are there. One class we take an item and we put it into the software and we apply loads to it to try to understand if something's going to break or fail before actually making it. So that picture there that says safety factor, that was our final project. We modeled a composite diving board, and we said, if my dad jumps on this one end with this amount of force, is this diving board going to break? And according to this graph, there will be some failures in the diving board. So I made sure to tell my dad not to jump on the diving board too much. And then on the other picture there is a work boot. That was my 3D printing project. I really hated tying my boots, and that was a problem that I had that I didn't feel anyone had solved. So I really wanted to see if there's something cool that I can do with 3D printing technology to solve that problem. So my idea was to come up with these little springs that allow the boot to expand and contract. So it would expand to slip my foot on and hold shut to keep my foot in without having to tie a shoe. But that didn't work because they all broke. But it was a great learning experience, and I went through many, many iterations to finally get to the final solution that I came up with, and then even that didn't work, but it was a great learning process through that. So I enjoyed my time at MSOE so much. I'll get to that later, but during my time there, I did lots of internships in the area, Milwaukee area. So my first one was at Western States Envelope and Label, where I was a manufacturing engineering intern. And the project that I worked on was this lower right photos, where we had to use these pieces that put adhesive onto the envelope, not the adhesive that you lick, but the stuff that actually keeps the 3 folds of the envelope together. So that was a really cool project where I got to design something. We had a really nice 3D printer. I got to make these parts, and then I got to make molds for the parts because we had higher quantities, and then I got to develop a process in order to keep the right amount of quantity in stock at all times to be used. So that was honestly probably one of my best internships. So if you're looking for anything, go check out Western States in Butler, Wisconsin. After that, I moved to Wildeck in Waukesha, where I was a design intern. So manufacturing, I did a lot of design, prototyping, and process engineering, whereas at Wildeck was really focused on the design, so really the front end stuff. So that's what this animation is that's playing, was I had to develop these large interlocking doors. There was one version, and I had to create basically a 2-sided swing of it instead of a 1-sided swing, and come up with some of these animations that we used in marketing. That was really interesting to learn how to design with steel, making things out of sheet and out of tube forms, thinking about how things are going to weld together, how you're going to bend things and press break them, and all the processes that go along with that. And then my last one in Wisconsin was very close to home in New Berlin at ACS Group, where I did mechanical engineering and new product development. So that's the top right photo there is one of our products that is a dryer and a hopper for plastic that goes into injection molding. So when you have an injection molded part, there's a lot of pellets, and these pellets need to be at the correct moisture level. If they're too wet or too dry, they don't mold very well. So that's kind of the products that we made, and I worked doing some fixture design and some testing on parts related to that. So after all that, I decided I wanted to continue my schooling in engineering. So I went to Stanford to get my master's, where I focused in design methodology and product realization. So design methodology is the front end. What are the needs? Where are the holes in the market that we can address? And how do we prototype this design and really kind of verify that we're actually addressing the need that's out there? And then product realization is really the manufacturing side of it. How do we make these? Do we want to use a mill or CNC or casting or injection molding? So that was really cool to get all the hands-on classes where I got to actually do a lot of those processes. And again there, since I liked Formula Hybrid so much, I found the solar car project, where we basically did a similar thing to Formula Hybrid, except our car was electric only and solar powered. So I was part of the battery and mechanical sub-teams, as well as the safety officer. And we had this really great car there. You can see number 16, the Black Mamba. We got to race it in Australia. We spent about 2 months out there, and we did all sorts of testing for weeks and weeks. And we finally get to the race, and about 30 minutes into the race, we blew up our battery pack, which is what you see there, up in flames. Thankfully, we were able to get the driver out and pull the battery pack out, so it burned on the side of the road while our car was still intact. But after that, we had to pack it up and trailer it across Australia. Overall, it was a really awesome experience, and I loved every minute of it. Some of the other items shown here on the lower right is a project that was my design methodology coursework. We focused on, basically our need was, how do we help people who are handicapped be able to handle autonomous vehicles as that becomes something new and in the future, because a lot of people in wheelchairs need people to help them throughout their day. How can we make these people take advantage of the autonomous technology that we have? So we have this little robot that helps hold a wheelchair in a car and moves it around. So that was a cool project I spent a whole year working on. And then the top right, the quick step, that was one of my manufacturing classes. again, you can see I went back to this boot problem. I really hated tying my boots. And so I went back and spent another, a month and a half working on this. So I actually developed an aluminum cast belt buckle that I still use to this day. It's holding up awesome. And it's just one quick buckle to go together. So I can't quite slip it on, but it's a major improvement. And everyone who sees it says that it looks really cool, and I love it. So while I was in California, I also did some more internships, because if you haven't realized by now, internships are super important and really awesome, and every engineer should do them. My first one was at Lumentum, which was over in Milpitas, California, where I was mechanical engineering, and I worked doing a lot of fixture design for testing of VCSELs, which are a fancy kind of laser. So these are what are used in 3D sensing. So the facial recognition in your iPhone, these are the lasers that work in there. They send about 30,000 points to recognize your face. So I worked on fixtures for testing those. Then my last internship was at Tesla. No, I did not get to meet Elon, as everyone wants to know. And I also did not have any part in the Cybertruck fiasco. So I worked in the battery engineering department on the module team. So the lower right photo there shows what a module is. So there's various levels of batteries. There's cells and modules and packs, and different ways that you basically build it up, kind of like Lego bricks. You take a few cells and you stick them all together in series and parallel, and you get some really big modules and packs that can power something like a semi. So those were the kind of packs that I worked on, were for the Powerwall and the semi. So that brings me to Aaronsco, where I've been for about 3 months. What really attracted me to working here was the electrification of the vehicles that's going on. So here you can see these are internal combustion engines driving the zero-turn lawnmower and the snowblower. But as the industry is moving towards electrification, that's kind of where we're going. So I thought that was a great match with my experience. Some things that I do on the day-to-day are component design. We have design engineers specifically for doing like the SolidWorks kind of stuff and handling all these very large assemblies, but we help a little bit with that. Prototyping, so when we do all sorts of testing to make sure that everything works before we give it to a customer. So starting with prototyping, then when we get to the development and production, we want to test the entire units themselves. So we can collect data, we evaluate durability, and also the quality of the products. How well does it actually cut the grass? And analysis is also a very important part. So instead of testing something in the field, if we can test many iterations of it on the computer to see if something yields or fatigues, that's really beneficial to us. Also the flow within the deck. So all the grass that's spinning around in there, we want to know what's happening in there, because that's not really something you can look at while the machine is working, but you can see it very well on the computer. So that's what I'm working on. I'm really enjoying it. I kind of talk about what it's like to be a woman in engineering, because this is something that I found very apparent through my career. So MSOE is very specifically engineering. So the entire population is only 26% female, 20% within mechanical engineering. Stanford engineering was really crazy, because going from MSOE for 4 years to Stanford for 2, to see that the entire population is 50-50. And like it says here, 34% within mechanical engineering is female. And our solar car race crew was 55%. So that was a huge difference compared to MSOE, and I really enjoyed it. You can see there our team working with all the people there. It was really great to see that kind of diverse work group compared to MSOE, where I feel kind of like everyone's similar, coming from the same background, same kind of demographic. And at Aaronsco here, I went through the entire engineering email list. We are only 6% female within engineering. So that is one thing that I hope we would like to increase as we get more engineers into the work field, especially in manufacturing industries within Wisconsin. So you heard me talk a lot about my education and internships. So I kind of want to explain the value of these things. So my first summer after freshman year, I did not get an internship, even though I had all those other internships afterwards. So I did a few interviews. I failed miserably. They were all really, really terrible, but they helped me prepare for my future interviews, where I did then land an internship, because I knew what kind of questions would be asked. I knew how to answer them. I had more experience from working on Formula Hybrid. People want to know what project you did, were there any issues, how did you address those issues, and what did you learn from it? And so having only been in school for like 2 months, I just couldn't answer that at the time when I was interviewing. But the following year, after having that experience, I was able to. Even getting into my graduate school and when I was trying to get internships, technical interviews still really suck. That's where people ask you a little bit about your project, and then they ask you to take out a piece of paper or go on the board and solve a problem, and those just really suck and everyone hates them. And you never know coming out of them if you did well or not, so those are just kind of a toss-up that a lot of big West Coast companies use because they have so many highly competitive people coming in to work for them. Internships have been really great because I got relevant experience in my field of study in addition to what I did with the extracurricular teams. So one thing, if you do get an internship, it's important to ask for work samples or to make a portfolio of your work. And you can even do this now in high school. So like my construction house that I had built, it would have been really great to make a portfolio of that, because your resume, it's black and white, it's just words. But that's a big thing, at least I saw at Stanford, was to have a portfolio where you go into more detail on all your projects. You have pictures, you explain what you were doing. So this was my senior design project. I have a page. You see that's page 7 out of, I don't know, 10 pages in my portfolio. I explained the analysis that I did in the computer software and the physical testing that I did to try and solve a problem that I was working with. So having that really helps you when you're going into an interview for an internship. People can see all the work that you actually did instead of just the note of MSOE senior design on your resume. Networking is something that people will always tell you got to do more of at career fairs, within internships, stuff like that. It's always great to have a great network because people are always looking for engineers. So even if you intern at one place, like it says here, try before you buy, you're there for a summer, but then you know engineers who are staying there for many years that can help you go back to that place, or they might have a friend that they went to school with who works at another company you might be trying to get in. So networking is always a great thing to do. I really enjoyed all the different internships that I had because they gave me such a different experience, each one of them. That really helped me when I was going into my full-time job, know what I want to look for within the company, within the kind of work that I want to do. So that was really helpful in that way. Obviously, kind of like Jill pointed out, you can get a lot of money in a STEM career out of school, making somewhere around $60,000 or more. Also in school, you can make good money. I always made, each summer when I went back to another internship, I made more and more money. So that's always something. Make sure you're earning what you're worth. Don't be afraid to negotiate. I negotiated my offer here. I've negotiated internship salaries, and also beware of the area that you're working in. So for a job here, I would make maybe $15 an hour at MSOE. And for that same internship, I would make $35 an hour in California. So a lot of people see that and they're like, oh man, I want to go California. Everyone's making the big bucks out there. But I was also paying $1,200 a month for a studio apartment, and that was a great deal. So always be aware of where you're working and kind of what the pay scale is in those areas. And finally, mechanical engineering is a super broad field. So as you can maybe tell from my different internships and education, I covered a lot of different areas, and that helped me narrow into what I wanted to do full time, which is this engineering kind of based in design and testing and working on vehicles. That's something that I always really enjoyed. There's not a whole lot of really exciting stuff going on working at an envelope manufacturing company, but working on vehicles is something that was really awesome. So that's why I knew that was what I wanted to do full time. So that's all I have to present. Thank you guys for your time. I'll send it back.
Thanks so much, Courtney. That was really awesome information, and it just reinforced what Jill was saying too about internships really can have a huge impact on you deciding what area in engineering you were really interested in.
Mm-hmm.
The New Manufacturing Alliance each year has a huge internship event at Lambeau Field called Internship Draft Day each November, where students compete. And at the end of the night, even the president of the Green Bay Packers announces the #1 draft picks, and we give away college scholarships. So again, I really appreciate your presentation. Thank you so much. And then
Thank you.
last, we have Taryn West, and she will be presenting next. Taryn, please.
Hi, can you hear me okay?
Yes.
All right, let me share my screen. So my presentation is a little bit shorter, but that's okay. So I am Taryn West. I was a fluid power designer. I'm now a project manager. So as Jill talked about, it's very easy to change careers once you're in STEM. And that was just a really easy flow because I did a lot of project management and fluid power design. So what is fluid power? It's using air or hydraulics, so air or oil, to create power. So I'll show you a couple examples in a little bit, but a couple of things I built ran robots or cranes. There's other really cool applications in the industry that run anything from a roller coaster to lifting like the London Eye or lifting a bridge. So there's a ton of applications for it, but it's really, hydraulic comes into play when you need a lot of force to do something. So my typical day for that was to understand what the customer needed in terms of their application. Either I would propose a component like a pump or a valve that would control the flow and the pressure. Otherwise, I would build a system. So taking a motor, a valve, and a pump to make a control system. So again, I'll show you that in a second. The math I really used was basic algebra. It was fluid power formulas, but I needed to understand more about physics. So how fluid works is very complex sometimes. I didn't do the full engineering degree where you really get into those details, but I had enough information in my experience that I learned how to determine what the best solution was. So now I'm a project manager. A project is basically any temporary endeavor that creates a product or service or process. So there's a lot of project management that goes on in engineering. So definitely be aware of that, but also it has a lot of skills that people don't realize that they have until they're in those projects. So I do some IT project management more now. So really what my job is working with an executive or sponsor and saying, what do you want to see from this project? And then from there, I help work with the team to develop a scope of the project. So what work we actually need to do, and then how we're gonna get it done. And then I don't actually do the work on the project necessarily, if that makes sense. But there are project managers that they manage the project and they do the work. And that's a lot of what engineers do, is they're assigned a project and they have to get it done. So they go through all the tasks themselves. So I work with people to facilitate decisions and work on issues, see things that are coming up, make sure we're preparing for things, stuff like that. So I have a MBA from St. Norbert. I also have electromechanical certificates from Fox Valley Tech. So like I said, I didn't go the full engineering route. There's only, MSOE is the only hydraulic or fluid power engineering degree in our state. So I wanted to stay local. I worked at a family business, so that's how I got involved in fluid power. And the electromechanical certificates were an excellent option for me at Fox Valley Tech. I really liked all the hands-on. And like Jill was saying, I could easily have finished that up and then transferred to another program. And then I am also project management certified. And another tidbit about me is I have my pilot's license. So that's really where I got interested in STEM. And I've always been very interested in how things work, like Jill was saying, and just understanding what I can do to create a solution. So using slides, so I'm not quite used to that. So these are a couple examples of things that I would help design or design. So this one on the left, it actually is a fluid, or it's a hydraulic power unit that runs a cheese plant. So it runs these machines that either cube a cheese or they shred the cheese or they make string cheese. There's so many different processes in cheese. It's actually kind of crazy to me. But this was a really cool application because they had multiple pumps so they could scale up or down. So like Julia was saying, manufacturing is 24/7, but it's not always full bore 24/7. So on third shift, they typically move down to a smaller production. So this allowed them to scale. The one on the right is a cool application. So what you see here are valves. They control the flow. So it basically, it makes things either move one way or another way or make something rotate. And there's an accumulator on the bottom. So it really allows for this is actually for a hydro dam to create power. So this will help shut and open the dam. And when they do that, they generate power from the flow of the water. And then like in Kakana, they fuel power that way, or they fuel the city that way. And then you can see there's a little electrical here. So that's where my electrical-mechanical comes in. Fluid power gets more into the mechanical aspect, but there's also then electrical controls that run what we are doing. So I needed to know that as well. So this is just an example of air. This is for, if I remember correctly, it's just opening and closing a lot of little air cylinders for an application. This could be anything from a measuring device to, they actually use air and cheese too. It's just not as much force there. And then this up here is just a little control panel. So it's all in one. And then getting into the project management, I was actually just a project manager at Aaron's Co., so where Courtney works now. They had undertaken a $30 million project to completely redo Plant 1. That's the lawn and garden plant. So as she showed you that zero-turn electric lawnmower, that's where this is going to be made. I don't have a before picture, but you can kind of see on the right, like it was grimy and dirty. So they wanted to clean everything up, but they also completely changed how they produce. So they, prior to this, had a bunch of carts where they would move the product around. Now it's all on conveyance or using automated vehicles. So these little AGVs drive around and deliver parts. Much more productive. They went from, I believe it was like 350 units a day to 500, which is a huge increase when you're talking these big complex lawnmowers that they have to build. And then part of that was implementing a new paint system. So that's where I got to use more of my technical skills again. The paint system ran on a PLC, so a programmable logic controller. I had that knowledge in the back, and that really helped me talk with the engineer on the manufacturing or the people who made the machine. It helped me talk to them and understand what exactly we were buying and what process it was. And then I would take that information and teach the production managers or the manufacturing leaders what the process is going to be. So I'd help walk them through it. So the company would obviously train us, but then we also needed to know so much ourselves. So why I got involved in, or what I like about my job, even project manager or when I was a fluid power designer, is I really love solving problems. That's something I've always really been interested in. I'm a lifelong learner, so I think there's always more to learn. And the awesome thing about science and technology is there's always new things. It's always changing. We're always finding out more information. We're always creating new things. So it's a very exciting field to be a part of. I also love making connections between things. So my boss and I were having a conversation when I was at Aaron's, and she realized I like to organize chaos. So it's like, okay, that's a great way to put what I do. So I like to understand how things fit together. And that's what makes me a good project manager, is I understand that this project over here is doing this one thing and it's going to impact this other project. So we need to be aware of that. So I make connections a lot and then figure out what the best way forward is. And in those connections, there's often issues. So as you can imagine, with a project this size, there were a lot of things we were dependent on, and there were a lot of things that were dependent on what we were doing. So there was a lot of moving parts that we had to keep track of. and it could be overwhelming at times, but the team was amazing at just going with it and rolling with the flow and continuing to solve what came next. So for classes wise, I mean, I took a lot of math classes. I've always been good at math. But like I said, the math I use is not extremely complex math. Now it helps to know how things work. I did a lot of CAD design in my last job, and I had to know how mechanics worked in order to build that CAD. I couldn't just go to CAD and say, oh, I know how to use this program, so I'll just design something. So it takes a lot of just understanding how things work and digging into those details. So why STEM? So I kind of got cut short on this presentation, but this isn't a fancy slide. But problem solving is huge. It's the best part of my job, and it's something I've always loved. So that's why STEM is a great fit for me. But it's also so cool to see how things are made and try to figure out a solution. So like Courtney was kind of talking about, not everything works right the first time, but it's good. It's always a good learning experience. So even if you don't get it right the first time, you learn from it and you create an even better product the next time. The outcomes are extremely rewarding. So like I said, that last large project I was on, it was really cool to see now where this plant has come in the last year and a half, and how much easier some people's jobs have become. They've added automation that just makes a job of lifting a deck. So those lawnmower decks, we have to bend those and weld those, and bending them is very unsafe in the old machine we had, because it's all by hand. So they were very good. The operators were very good at what they did, so they didn't get hurt because they knew the safety precautions, but we couldn't put anybody in that role. So now they have an automated bending cell that you just fill it with flat stock and it bends everything for you. So it was really cool to see that transition. I've also created or helped with projects that create a new process. So one of the products I was on rebranded things and really increased our brand awareness for our service parts. We would just send them out just as a part, but now we're trying to get into the branding so that people recognize, yep, this is coming from Aaron's, and it's a manufactured product from them. So it's not a third-party product that might fail. In fluid power, that was very rewarding to see my system that was designed get built and shipped to a customer, and I would go visit it afterwards. And it was awesome to see how happy the customers were. I had one product that it usually took a guy or two guys all day to remove this ball stud on this large construction truck, because they'd have to lift the truck up and hammer on it. And we built an application that allowed them to hammer it hands-free, basically, with a jackhammer, tipped upside down, and ran with fluid power. And they got it done in 30 seconds. So it was really rewarding to see how we can make people's lives easier, but also just what cool applications we could come up with and what it ran. So that's really what got me involved in fluid power. Is I talked about, well, we built things that made cranes work. When I was 14, I worked at the family business building hydraulic loop panels, and that would go on a on a crane and basically help the crane run. So without that, it wouldn't control, you wouldn't be able to control the arm forward and back, up and down. So I just thought it was the coolest thing that I could build something that did such a huge application. So yeah, I don't know if you have any questions for me, Anne, but that's my presentation.
Great. Thanks, Taryn. That was really very informative, and I like the idea about the chaos that you can bring all that together and manage that.
Yeah.
I'd like to thank each one of you for joining us today and sharing a little bit about your story and about why you enjoy working in the STEM field. Thanks so much, and we look forward to talking again to just help women see that their career could be wonderful in the STEM field. Thanks again.
Thanks, Anne.
And then
Thank
I
you.
am going to stop recording.